tropical trees inside a very modern steel and glass architecture. We are here in Covent Garden, a meeting center of the European Commission, deep in the heart of Brussels. And we are here to attend an important milestone of the ALTAIR project, a Horizon 2020 project of the European Union. So you have to kind of bring with you a logo.
Yeah.
Maybe let's use this logo for a quick dive through on the project and tell us a bit like what ALTAIR is about.
What you see on this logo is a vehicle on which we are working. So it is a space transportation system whose goal is to launch small satellite into orbit. The payload is about 150 kilo. And what you see on the picture actually explains the core principle of this concept. This is an air launch system, meaning that instead of starting from the ground, the rocket is carried by an aircraft. It is brought at 12 kilometers of altitude, and then the rocket is released and the rocket engine is ignited. The rocket that is used for this system is smaller than the equivalent rocket starting from the ground.
The name ALTAIR, I know that this is like a great star. It's like the 12th brightest star in the sky, the main star of the constellation of the Eagle, Aquila.
Yes.
Why does the name ALTAIR came to that project?
ALTAIR is Arabic from flying eagle, hence the name of the constellation. And so this is quite appropriate for an air launch concept using a reusable carrier to be called Flying Eagle.
I work for Piaggio Aero Industries, one of the oldest manufacturer of aircraft in the world, and we are involved in two work packages. The first one is concerning the design of the carrier of the project, and the second one is concerning the flight test experiments. We have two pictures. It explains the aircraft itself and the concept of the aircraft. As you can see, the aircraft is a little bit different from common aircraft because of its mission. We can see that the aircraft, which has the weight of more or less a A320, is quite different from this commercial aircraft because we have two booms, two fuselage, and inside, under the wing, in the central part of the aircraft, we have the launcher that has to be released in order to put some satellites into the space. And the innovation of this concept is not only on the design of the concept itself, but also in the fact that the aircraft is an unmanned aircraft. It means that there is nobody inside the aircraft. It's remotely piloted and or autonomously piloted.
Okay. I understand now why the aircraft has no wings, because there's nobody on board, but why do we have two structures, two fuselages?
Yes, we have two fuselages because we need to have one fuselage in order to have an aircraft, but since we have to put the launcher inside the aircraft and we want not to put the launcher inside the boom, the fuselage, we preferred to insert two different booms. And we have two different booms to have the aircraft symmetric.
So how does the release in fact work? So how do I have to picture that one? I see that you have another photo here or another graphic.
Yes, here you can see the release how will it perform it. The aircraft take off like a common aircraft from a runway. It flies until it reaches its operative altitude, and it performs a maneuver that will put the aircraft together with the launcher in certain conditions that are optimized to start the engine of the launcher. At these conditions, the carrier will release the launcher with the mechanism that is included inside the central pod. And while the launcher will go further in its mission, starting the engine, the carrier will turn and will go back to the base in order to be arranged for the next mission. So while the launcher is not reusable, the carrier is reusable.
So you said it's to be made ready for the next mission. When could the next mission then take place? How long does it take for you to do all the maintenance and get it ready again?
Yeah, the maintenance and all the procedures are quite short. In fact, we plan to have, in the best case, 30 missions per year. It means that we have a mission more or less 1 week and a half, so 10 days more or less between one mission and another one.
This is an air launch concept, which is mixing an airplane and a rocket all together. So such system is existing but has not already been fully designed from the start and optimized, and that is the goal of the ALTAIR project and the interest of such mixing two different vehicles, two different worlds, the aeronautical one and the space one, to optimize a fully new concept for launching satellites efficiently. Motivating from the ONERA side on ALTAIR is the experimental part, because the ALTAIR project is to go up to some experiments to flight-proof some technologies. It's really motivating to have all these bricks, separate bricks, coming all together in an integrated concept that will partly fly and will be defined at the end of the project.
So is space, like most people believe like space is like a completely traditional thing, hasn't changed over the last 20 years or 30 years. Do you share that opinion, or like in your opinion is it a bit different?
You're right, for 30 years space was really stable. No major change, no major changes. There are around, let's say, a market for 20 big satellites in geostationary orbit. But now, currently, it's completely changing. There is what we call the new space business, new private company, new small companies, with new markets, new application, Internet of Things, machine-to-machine, observation, Internet everywhere in the world. And so this will be done by constellation of satellites, of small satellites, and that's why we need small launch vehicles, small rockets, to put these small satellites into the right orbits. So of course this system will be complementary with other systems, other big launchers, but we need to have this dedicated system for the maintenance of the constellation, and there is really a market for that.
So there are a few competitors out there, right? There's Launch, there's Pegasus rocket, of course, still there. How do you see that competition?
There is currently more than 80 concepts in the world.
80? 80?
80, yes. Mm-hmm. So it's very impressive, a large number, but at the end, only few will survive.
I'm from CNES, the French National Space Agency, and my role in the ALTAIR project is to think about how to develop the ground segment that will host the future ALTAIR, so the launch vehicle and the carrier. You must know that at the ground segment we really need to be ready in order to host all of it. So both the preparation of the space part of this project, the launch vehicle itself, but as well as the carrier, which looks actually as a standard aircraft and needs not much of what one could think space stuff. But even so, they need to live together, they need to be prepared in parallel, and they need to meet at a certain point in order to be ready for the final launch.
You've shown us a really, really cool video, and I was wondering, this video, was it representative only for Kourou, or could this be anywhere in the world, any runway?
Yeah, it could be anywhere in the world actually. In this video there was nothing particularly really linked to Kourou itself. So the ALTAIR system is a system which can be actually exploited anywhere in the world. What it needs is some facilities, especially to prepare the satellites that, as you know, are very sensitive to our external environment and need to be protected from the outside and from particle pollution in particular, and the building in order to make the assembly of the launch vehicle with the satellites. So those two buildings are standard buildings. They can be actually set up anywhere. We can even reuse existing building in facilities. So it's not really depending on Kourou and French Guiana. It could be Europe, it could be anywhere in the world.
Since you're dealing with structures, I brought with me a logo, which shows us the carrier and the rocket, of course.
Yes.
So what are you dealing exactly with here?
So basically the picture here shows the overall system architecture, and the part I'm dealing with is the rocket, which is basically suspended under the carrier. And so we're designing all structural components of this rocket. And what's special about the system is that we have very, very high structural loads as the rocket is suspended under the carrier, as opposed to a conventional vertically launched rocket. And this imposes several challenges to the design of the structures, because of course we want to be as efficient as possible. And to achieve this, we design most load carrying components in composite construction. So using high performance carbon fiber reinforced plastics to increase the structural efficiency and eventually the overall performance of the launcher.
I'm not sure if you're aware, but I'm a VIP, a very ignorant person. So what's the special load on this rocket? I mean, it looks to me like a normal rocket.
Yes, it looks like a normal rocket, but the major difference is that it's not vertically launched from the ground, but air launched from a carrier aircraft. So as opposed to a conventional rocket where the loads are mainly pure compressive loads on all the aerostructures, we have high transverse loads and bending moments because the rocket is suspended under a carrier. So when the carrier undergoes maneuvers or gust loads, this imposes high structural loads on the launch vehicle.
You have shown us yesterday a very nice animation.
Yes.
With the Earth and the rocket just taking off. What did we see there?
We've seen proof of concept of the Bertin, which is another partner of the ALTAIR project, orbital module, which they propose a very innovative orbital module configuration. And we were trying to do for them is try to prove from a guidance and control point of view that new orbital module system can be controlled successfully to accomplish the ALTAIR mission.
So there's a piece of software you've shown us. Did you develop it completely yourself, or is it like just taken from something else and then a bit like...
No, in that case, and to take advantage, it's one of the key, from my point of view, the key of the H2020 European projects. We developed that software during the H2020.
Very interesting was your presentation about the avionics that you gave. And I was wondering, we're talking about an unmanned aircraft here.
Yes.
Is this a particular challenge for you, knowing that there's nobody on board, or does it make the job easier?
It makes the job not easier. It makes the job challenging and interesting, but surely not easier. To make that an equivalent in the ground segment, we found nowadays that automated cars, from an aeronautic point of view, is not that different. We have to deal with the advantages of having that kind of carriers, the kind of aeronautic systems, but we have also to deal with the problems of having that kind of aeronautic systems. With, like the cars, it's mostly safety. The most feared event, and considering previous experiences in French Guiana, it's the fact that we have a system which is autonomous, which is flying off the launch range, and after the mission, it's coming back to us. So when you have something which is autonomous and it's coming towards the launch range, there is people and goods. It's the landing of the carrier once back in the base.
And I'm working for the ground segment for the Launcher Directorate, and we are responsible for some of the ground segment activities.
So what does the ground segment include?
The ground segment includes all the means that are needed to prepare the launcher and to follow the launch after the liftoff.
Okay, so if I look at the movie like Apollo 13 and stuff like that, it's really like that you have all these consoles where the guy watch how the rocket performs, and did you fill the rocket before and you put in the satellite, or is it bigger than that?
Yes, it's exactly what you say. All the means that you need to assemble the launcher, to prepare it, to test it, to fill it, to prepare the payload as well, and to put it on the launcher, and then to proceed to the launch, and to follow the launch after liftoff.
Oh, I'm working for ONERA, and I am the work package 6 leader, so the work package dedicated to the flight tests, and I am involved in the flight test with the EOL demonstrator.
What does it all mean, by the way?
EOL is a subscale demonstrator for air launch to orbit systems, so it's a flying test bed when we will carry some subsystems to test some ALTAIR equipment.
And how can I picture that? Yes, it's small scale. What is a small scale aircraft? It's not a model aircraft, right? It's bigger than that.
In fact, EOL is a 6.7 meters wingspan.
Okay.
It is a quite big experimental system, but it is not an operating system. It is an experimental vehicle. It has 2 bombs like for the ALTAIR carrier. And in fact, we will use this, it's a UAV, to carry some subsystems from the ALTAIR. So we have a launcher mock-up derived from the ALTAIR launcher. And we also have a relay system representative of the ALTAIR relay system.
So at a certain point you will really carry a mock-up of the rocket and you will really drop it?
Yeah.
Wow.
Yeah, it's a very ambitious goal.
But the
within
rocket
the ALTAIR
won't be fired, right? It just comes down with a parachute or so, right?
No. It will be a non-piloted rocket, just with a ballistic flight after the release. But we have part of flight which is about the launcher onboard system, so we have part of flight which are interesting even in the captive flight. And after that, we will have a release of the launcher, doing a separation maneuver, and we will have a ballistic flight of the launcher.
What was the biggest challenge you faced during the whole project?
Well, one of the big challenges is really the number of different subsystems that need to be designed. So there are quite many different structures that we had to address, including like the aerostructures, which make up the outer airframe of the launcher, the mechanical interfaces, the separation systems, the tanks. So it's really different structures which need to be sized and optimized.
The most challenging thing is to optimize the overall system. You can optimize the launcher on one side, you can optimize the airplane on another side, you can optimize the ground facilities on a third side, but optimizing it all together and make it work efficiently is the most challenging task.
ALTAIR is something new, is something different, is something which is born from the new space somehow. We wanted to do it in an efficient way and in a cost-effective way.
We have some ideas to have some very interesting business cases. So we're studying options and we are looking to the best one for this project and to have a very competitive European industries. 3 wishes can be a long life to ALTAIR.
Okay.
And the other one is high up ALTAIR to meet investor so that this can continue. And I hope the best for all the people who worked for this beautiful project.